All right, hi Calc students. Today I'm going to go over how to use u-substitution to solve for integrals. So first of all, what is u-substitution? Now this is just a method or a technique that people use to solve a complex integral. So what do I mean by a complex integral? All I mean by that is this is when there's a function divided by another function, the integral of a function divided by another function, or we have a function inside of another function. Now, this may look really strange, but all this means, an example of this would just be like sine of 2x. It'd be something like that. Now, there are a couple steps you need to take to solve for this. So first of all, you need to know, when do I need to use u-substitution? So obviously, if you have a simple problem like the integral of sine x, you already know the antiderivative. There's no problems there. But if we see like multiplication like this, then okay, now we need to use u-substitution. Or if you see something like sine of x squared, or here, that's not really a good example, of sine of 2x, I'll just use the first example, sine of 2x, now we see, okay, there's a function inside of another function, so we should probably use u-sub here. And also, you should know that when solving u-sub, whatever you pick for u to be, the derivative of u has to be able to cancel out. So I'll explain what that means later, but it'll make more sense once we get into examples. So here's our first example. So first of all, your first step in solving u-subs are, you need to find what does u equal. And to find that, the first step you want to take is, if there's a function inside of another function, that is always going to be your u. So here we have 4x, that's just a regular function, times, we have a function here, 2x squared plus 3, inside of this, the power 3. So we know this function on the inside is going to be our u. So u is going to equal 2x squared plus 3. Now, another way to find u is if you have a fraction, your u will always be the denominator. So if there's a function down here, this will be your u. So that's just two ways to find your u in case you're struggling. Always pick the one on the inside. So now that you do that, your next step for solving is you need to take the derivative of this. So du dx will equal, you can do power rule of this, so 4x, and this is just a constant, so plus 0. And now, after you find this, we need to cancel out this dx. So we need to solve for dx. So I can times dx to both sides. I get du equals 4x dx, and then divide by 4x. So now I have du over 4x equals dx. So now I can sub in all my u's for everything in this equation. So now I have the integral of 4x times, this is u to the third power, and instead of writing dx, we have du over 4x, because that's what this equals here. So now that we have that, we can see this 4x cancels out with that, which is why you have to make sure that this derivative will cancel out. So now we have the integral of u to the third power du. And now that these match, these have to match for you to integrate. So now that we have u and u here, we can just integrate using our simple rules. So this will just be reverse power rule, where we plus 1 divide by whatever we get here. So it'd be u to the fourth power divided by 4, and then plus c. And now your final step is you're going to plug this equation back in for u. So now you're going to get 2x squared plus 3 to the 4th power all over 4 plus c. And that's your answer. So that one seemed pretty nice and simple, but that's probably our easiest example. So now we're going to move on to a little bit harder one. Now this one right here, as you can see, what do you guys think our u is going to be? Now remember, you're first looking at, okay, is there a function inside of a function? And there actually is, and it happens to be in our denominator. So this actually checks both the boxes. So you're going to pick cosine of x, because that's inside of the 5 square. Inside of the power of 5. So u is going to equal cosine of x. Now we're going to find the derivative of u. Du dx will equal negative sine x. And here's a little shortcut. You don't need to always write out solving for dx. It'll always be du over whatever this is. Negative sine x equals dx. And now you can just start plugging it in, and we'll see what we get. So we're going to get the integral of sine x over u to the 5th power times du over negative sine x. So now you can see these sine x's cancel. There's still a negative here, so we're going to bring this negative out because it's a constant. This would just be negative 1. So I'm going to bring this negative out. So negative 1 over u to the 5th power du. Now u to the 5th power, or 1 over u to the 5th power, is the same thing as saying u to the negative 5. And that just makes it easier to use the reverse power rule. So now you're going to plus 1 and divide by whatever you get. So this will equal negative u to the negative 4th power over negative 4. And then don't forget your plus c. Now you could simplify this. This would just be negative, or the negatives will cancel here because negative and negative. This would just be 1 over 4u to the 4th power. And now you can plug in your cosine of x, because u equals cosine of x. So this will be 1 over 4 cosine x to the 4th power plus c. So that's going to be your answer for this one. And now we're going to move on to solving it with a definite integral. So what does that mean? That means we have to plug in these limits of integration, and we're actually going to get an answer. We're not just going to get an equation. So we're going to do the same thing. First, we got to pick out what u equals. So u should equal this function right here. U equals 5x squared plus 1. So we're going to take the derivative of this again, which will just equal 10x. And now we're going to start plugging the stuff in. So note, I'm not going to write these limits of integration yet, because I'm going to need to substitute these out later. So I'm just going to start writing this part first. U squared, and then du over 10x equals dx. So du over 10x. So now look here, the x's will cancel, but we're left with this 10. So what do we do with the 10? Well, it's the same thing with the negative sign, how we brought the negative out. So we can bring, this is a constant. This is the same thing as 1/10. So we bring out 1/10 to the integral of u squared du. And now we need to plug in these. So how are we going to get these? Because these limits 1 and 0 are in relation to x. And we are all u's now. So we need to make these x's into u's. So what you do is you plug it into this equation here to transfer it into u's. So first we're going to plug in 0. So 5 times 0 squared is just 0, plus 1 is 1. So this bottom one, 0, becomes a 1. Now we're going to plug in the 1. 1 squared is 1. 1 times 5 is 5. 5 plus 1 is 6. So now we have new limits of integration. Now that's very important. You can't forget that step, because if you forget it, your answer will be wrong. So now we just take the antiderivative of this, which is 1/10 times u to the third power over 3. And you're going to find this from 6 to 1. So that means we're going to plug in a 6 here and then minus it by when we plug in a 1 here. So this will be the same thing as u to the third power over 30 at 6 and 1. So 6 to the third power over 30 minus 1 to the third power over 30. And that'll equal whatever your answer is. I'm not going to actually write out the answer because I don't have my calculator right now. But if you follow those steps, you'll get the answer. Okay, now I'm going to show you guys a couple of shortcuts that are going to make your life a lot easier that you guys should definitely be using. So the first one is if you're trying to find the integral of 1 over any type of linear function. If this is the case, then a little shortcut you can use is the antiderivative will always equal ln of that linear function divided by the slope of the function. So that might look a little weird, but I'll show you guys. Watch. The integral of 1 over, we'll say, 2x plus 1. Now, usually if you use u sub, you would have to do u equals 2x plus 1, du dx would equal 2, and then you get this whole thing where it'd be 1 over u times du over 2, which would be 1/2 ln u, and then you sub the u back in, it'd be 1/2 ln 2x plus 1. That is a lot of work to do for this simple problem. Instead, what you can do is, if you're taking the integral of 1 over 2x plus 1, you can just use this little shortcut. So the shortcut says ln of the linear function divided by the slope. So you just take ln, the linear function is 2x plus 1, divided by the slope, which is 2. And look, these are equal. You can write it as 1/2 if you want, but like they're already equal. And that's just a lot easier. And you guys should memorize that because that's a really good shortcut for you to have. Another shortcut you have is any function with a linear function inside of it, you can do a little shortcut. I'll show you. So let's use e as an example. So e to the power of a linear function. If you're taking the integral of this, this will always equal e to that linear function divided by the slope of that function. And this trick works the same thing with sine. It works with cosine. It works with all the trig functions where it'd be, or not all the trig functions. It works with sine and cosine where it'd be sine, the integral, here I'll use cosine because that's a better example. The integral of cosine will equal cosine of a linear function will equal cosine of that linear function divided by the slope. Now keep in mind, these have to be linear functions in all of these. So you're going to get a lot of problems where it's going to be like 1 over 2x plus 1, or e to the 2x, or sine to the 3x. But note that if you get e to the x squared, this doesn't work. Or if you get 1 over x squared, that doesn't work. All right. Okay, so to do a quick little recap, we learned that to find u sub, your first step has to be to pick your u, which you'd pick it by either picking the function inside of a function, or you can pick the denominator. And then we also learned that if it's a definite integral with limits of integration, you have to sub the x's out for u's. And you do that by plugging it into your u equals whatever. And the last thing we learned was that if we have anything to a linear function, a shortcut would just be ln of that linear divided by the slope. So that's the basics of u substitution. And the last thing you should remember is this will only work out if the derivatives cancel out. If the derivative doesn't cancel out, then you're going to have to do another method, which is called integration by parts. And that will be a whole nother video for another day. So thanks for watching. If you guys need any help with anything else, just let me know.